almost all the elements known to us at present, except the inert gases, are present in the Earth's crust. The elements do not exist in the Earth's crust as such. Each element is in combination with one or more other elements to form definite chemical compounds known as minerals. Many of these minerals in turn combine together to form aggregates which we know as rocks. A rock is a solid aggregate of mineral grains. There are three main classes of rock: igneous, sedimentary and metamorphic. Definition of mineral. A mineral is a homogeneous, naturally occurring, solid and generally inorganic substance with a definable chemical composition and an orderly internal arrangement of atoms. The explanation for its attributes are as follows. Homogeneous: something that is the same through and through, cannot be broken into simpler components. Naturally occurring: minerals are the result of natural geological processes. Man-made minerals are called synthetic minerals. Example, industrial diamonds. Solid: minerals must be able to maintain a set shape nearly indefinitely. Liquids are not minerals, exception mercury. Definable chemical composition. A mineral can be described by a chemical formula. Example, quartz SiO2, diamond C, carbon. Orderly arrangement of atoms. Minerals have a fixed atomic pattern that repeats itself over a large region relative to the atom. A glass is not a mineral because it has no organized structure. Generally inorganic. Only a few organic substances are considered minerals. All other minerals are inorganic. Occurrence and formation of minerals. Minerals form in all geologic environments and under a wide range of chemical and physical conditions such as varying temperature and pressure. The four main categories of mineral formation are igneous or magmatic, in which minerals crystallize from a melt; sedimentary, in which minerals are the result of sedimentation, a process whose raw materials are particles from other rocks that have undergone weathering or erosion; metamorphic, in which new minerals form at the expense of earlier ones owing to the effects of changing, usually increasing temperature or pressure or both, on some existing rock type. Metamorphic minerals are the result of new mineral growth in the solid state without the intervention of a melt as in igneous process; and hydrothermal, in which minerals are chemically precipitated from hot solutions within the earth. The first three processes generally lead to varieties of rocks in which different mineral grains are closely intergrown in an interlocking fabric. Hydrothermal solutions and even solutions at very low temperatures, example groundwater, tend to follow fracture zones in rocks that may provide open spaces for the chemical precipitation of minerals from solution. It is from such open spaces, partially filled by minerals deposited from solutions, that most of the spectacular mineral specimens have been collected. If a mineral that is in the process of growth as a result of precipitation is allowed to develop in a free space, it will generally exhibit a well-developed crystal form which adds to a specimen's aesthetic beauty. Similarly, geodes, which are rounded, hollow or partially hollow bodies commonly found in limestones, may contain well-formed crystals lining the central cavity. Geodes form as a result of mineral deposition from solutions such as groundwater. Classification of rock-forming minerals. Rocks are the earth materials made from minerals. Most of the rocks have more than one kind of minerals. For example, granite has minerals like potassium feldspar, plagioclase feldspar, quartz, hornblende, biotite, and may still have more. Some rocks have single mineral, for example, limestone. Limestone has calcite mineral and rock salt has halite mineral. Mineral classification. Minerals that form rocks are classified in various ways. They are classified based on time and origin, visual properties, physical properties, and chemical properties. Types of physical properties that geologists use include color, streak, luster, hardness, specific gravity, crystal habit, and cleavage. They are also classified based on special characteristics like reaction to acid, calcite and dolomite, magnetic property, magnetite, salty taste, halite, etc. Classification of minerals based on time of origin. Based on the time of origin essentiality of minerals that form rocks, the minerals are classified into three classes, namely primary mineral, secondary mineral, and accessory mineral. Primary minerals. Primary minerals in an igneous rock is any mineral that formed during the original solidification, crystallization of the rock. Primary minerals include both the essential minerals used to assign a classification name to the rock and the accessory minerals present in lesser abundance. Important primary minerals: quartz, silicon dioxide, orthoclase or feldspar, potassium aluminium silicate, plagioclase or feldspar, calcium or sodium aluminium silicate, muscovite or mica, potassium aluminium silicate hydroxide, biotite or mica, magnesium or iron may replace aluminium, hornblende or amphibole, combination of calcium, aluminium, magnesium and ferric silicate hydroxide, augite or pyroxene, combination of calcium, aluminium, magnesium and ferrous silicate, olivine, magnesium or ferrous silicate. Secondary minerals. In contrast to primary minerals are secondary minerals which form at a later time through processes such as weathering and hydrothermal alteration. Primary minerals form in a sequence or in sequential groups as dictated by the chemistry and physical conditions under which the magma solidifies. Important secondary minerals. Clay minerals are kaolinite, montmorillonite, non-silicates, oxides, ferric oxide or hematite, iron oxide hydroxide or geothite, aluminium hydroxide or gibbsite, carbonates, calcium carbonate or calcite, calcium magnesium carbonate or dolomite, sulfates, calcium sulfate or gypsum. Accessory minerals. Accessory minerals form at various times during the crystallization, but their inclusion within essential minerals indicate that they often form at an early time. Accessory minerals are any minerals in an igneous rock which are not essential to the naming of the rock. When it is present in small amounts, as is common, it is called a minor accessory. If the amount is greater or is of special significance, the mineral is called a varietal or characterizing accessory and may give a varietal name to the rock. Example, the mineral biotite in biotite granite. Accessory minerals characteristically are formed during the solidification of rocks from the magma. In contrast are secondary minerals which form at a later time through processes such as weathering by hydrothermal alteration. Common minor accessory minerals include topaz, zircon, corundum, fluorite, garnet, monazite, rutile, magnetite, ilmenite, allanite and tourmaline. Typical varietal accessories include biotite, muscovite, amphibole, pyroxene and olivine. Felsic-mafic classification. It was proposed by Norman Levy Bowen. Felsic-mafic classification is based on relative color of minerals. Chemical composition of igneous rock can often be estimated just from looking at the rock. Geologists look at the proportions of light colored and dark colored minerals in an igneous rock to estimate the chemical makeup of the rock. Light colored or felsic minerals have more silica in them. Silica is one of the most abundant elements on earth and is the chief component of quartz. Felsic minerals are most often colorless, white, grey or pink, but can be any number of colors. The dark or mafic minerals are richer in iron and magnesium. Mafic minerals are chiefly black, brown, dark grey and sometimes green. The mineral proportions of the rock are what allow geologists to classify rocks chemically. Depending on the proportion of light minerals to dark minerals, igneous rocks can be broken into 4 main types: felsic, intermediate, mafic and ultramafic. The following list gives more information about igneous chemical categories. The term mafic combines the alphabets Ma from magnesium and Fic from ferric. Felsic combines the alphabets Fel from feldspar and Sic from silica. Felsic rocks are high in silica, 65% plus. They are usually light colored. Some examples are rhyolite, extrusive, and granite, intrusive. Intermediate rocks have lower silica content between 55 to 65%. They are darker than felsic rocks but lighter than mafic rocks. Some examples are andesite, dacite, extrusive, and diorite, grandiorite, intrusive. Mafic rocks have low silica content between 45 to 55%. They are usually dark colored and contain iron and magnesium. Some examples are basalt, extrusive, and gabbro, intrusive. Basalt is the rock that is produced at spreading ridges and makes up the sea floor. Ultramafic rocks have extremely low silica content, less than 45%, and contain large amounts of iron and magnesium. They are usually dark colored, but high olivine content can lend green shades to the rock. Other rare colors can be found. An example of ultramafic rock is peridotite, intrusive. Classification based on silicates and non-silicates. This classification system is called Berzelius classification in honor of the Swedish chemist and mineralogist Johannes Jacob Berzelius. 98.5% of crustal mineral mass is formed from 8 elements: oxygen 46.6%, silicon 27.7%, aluminium 8.1%, iron 5.0%, calcium 3.6%, sodium 2.8%, potassium 2.6%, magnesium 2.1%, all others 1.5%, of which oxygen and silicon combinations make up 74.3% of natural minerals. Based on this factor, they are classified as silicates and non-silicates. Nowadays, this classification is generally accepted worldwide. Non-silicates are further classified into 6 groups. Hence, there are 7 major mineral groups: silicates, native elements, halides, carbonates, oxides, sulfates, sulfide, silicates. Silicates are composed of silicon-oxygen tetrahedrons, an arrangement which contains 4 oxygen atoms surrounding a silicon atom. Silicates comprise the majority of minerals in the Earth's crust and upper mantle. Over 25% of all minerals are included in this group, with over 40% of those accounting for the most common and abundant minerals. Feldspar, quartz, biotite and amphibole are the most common silicates. Silicates are further classified into 2 categories based on iron-magnesium content and polymorphism: ferromagnesian and non-ferromagnesian silicates. Silicates are often divided into 2 major groups: ferromagnesian silicates and non-ferromagnesian silicates based on iron-magnesium content. Ferromagnesian silicates contain iron or magnesium ions joined to the silicate structure. Because of iron, they are darker and have heavier specific gravity than non-ferromagnesian silicate minerals. Ferromagnesians include minerals such as olivine, pyroxene, hornblende and biotite. Non-ferromagnesian silicates contain no iron or magnesium. Quartz, potassium feldspars, plagioclase feldspars, muscovite, also clay, are the examples. Polymeric silicates. A complex form of other materials often surrounds silicate because of its ability to polymerize. The silicate group has been subdivided into a number of smaller groups using their mineral structures as a basis. These include tectosilicates like quartz, feldspars, zeolites. Tectosilicates or framework silicates have a 3-dimensional framework of silicate tetrahedra with the SiO2 or a 1:2 ratio. This group comprises nearly 75% of the crust of the earth. Tectosilicates, with the exception of the quartz group, are aluminum silicates. Phyllosilicates like micas, serpentines, clays, chlorides. Phyllosilicates or sheet silicates form parallel sheets of silicate tetrahedra with Si2O5 or a 2:5 ratio. Inosilicates like pyroxenes, pyroxenoids, amphiboles. Inosilicates or chain silicates have interlocking chains of silicate tetrahedra with either SiO3 1:3 ratio for single chains or Si4O11 4:11 ratio for double chains. Cyclosilicates like tourmaline, beryl. Cyclosilicates or ring silicates have linked tetrahedra with T into O3 into 2x or a ratio of 1:3. These exist as 3-member T3O9 into 6 and 6-member T6O18 into 12 rings, where T stands for a tetrahedrally coordinated cation. Sorosilicates like epidote, vesuvianite. Sorosilicates have isolated double tetrahedra groups with Si2O7 into 6 or a ratio of 2:7. Nesosilicates like garnets, olivine, aluminosilicates. Nesosilicates or orthosilicates have the orthosilicate ion which constitute isolated insular SiO4 into 4 tetrahedral that are connected only by interstitial cations. Native elements. Native elements are minerals that are composed of a single element. Some examples are gold, silver, copper, iron, diamonds, graphite and platinum. Halides. Halides consist of halogen elements chlorine, bromine, fluorine and iodine, forming strong ionic bonds with alkali and alkali earth materials, sodium, calcium and potassium. Some examples include halite and fluorite. Carbonates. Carbonates are anionic groups of carbon and oxygen. Carbonate minerals result from bonds between these complexes and alkali earth and some transitional metals. Common carbonate minerals include calcite, calcium carbonate, dolomite, calcium or magnesium carbonate. Carbonate minerals react when exposed to hydrochloric acid. Geologists will often carry dilute hydrochloric acid in the field to test if a mineral contains calcium carbonate. If the mineral fizzes when it comes in contact with hydrochloric acid, it contains calcium carbonate. Some cola soft drinks can also be used for this test because it contains enough hydrochloric acid to react with the calcium carbonate. Oxides. Oxides are minerals that include one or more metal cations bonded to oxygen or hydroxyl anions. Examples of oxides include hematite, magnetite, corundum and ice. Sulfates. Sulfates are minerals that include SO4 anionic groups combined with alkali earth and metal cations. Anhydrous, no water, and hydrous, water, are two major groups of sulfates. Barite is an example of anhydrous sulfate and gypsum is an example of a sulfate. Sulfides. Sulfides are minerals composed of one or more metal cations combined with sulfur. Many sulfides are economically important ores. Pyrite or fool's gold, galena, cinnabar, molybdenite are a few commonly occurring sulfide minerals. Important rocks and their composition of essential minerals and most common accessory minerals. Many minerals have compositions that vary within certain bounds. For example, olivine may vary in composition from the species phyalite, which is iron silicate, to forsterite, magnesium silicate, and have any proportion of iron and magnesium in between. The pure forms are known as end members. Additionally, there are always minor substitutions of trace elements for major elements within the crystal structure. For example, manganese and calcium may replace a small proportion of the iron or magnesium ions in olivines. While these do not affect the overall characteristics of the mineral, they may be responsible for variations in some properties, particularly color. For example, the Hope diamond is blue because of trace substitutions of boron for carbon ions. All minerals fit into one of the 7 crystal systems based on the internal symmetry of crystals and the relative lengths and orientation of their axes. This is reflected by the faces of the crystals that have undergone unrestricted growth. This is a physical rather than a chemical property. The commonly occurring rock forming minerals are as follows: igneous rocks, granite, predominant quartz 20 to 35 orthoclase, hornblende, mica, magnetite, cyanite, predominance quartz 100% plus of orthoclase, nepheline and albite, hornblende, biotite and magnetite, granodiorite, intermediate quartz plagioclase exceeds orthoclase, hornblende, biotite, magnetite, diorite, intermediate quartz absent plagioclase, hornblende, biotite and magnetite, gabbro, labradorite, augite plus olivine, hornblende, ilmenite, dolerite, hyperbisulfite texture, hornblende, ilmenite, basalt, volcanic microcrystalline with glassy mass, hornblende, ilmenite. Sedimentary rocks, sandstone, mainly quartz with same contents such as calcium carbonate, iron oxides and clays, shale, clay minerals, quartz and some organic matter, limestone, mainly calcite or calcite and dolomite with some iron oxides, clay phosphate and organic matter, metamorphic rocks, gneiss, formed from granite, mineral composition like that of granite, schist, formed from basalt or shales, mineral composition much as that of original rock, quartzite, formed from sandstone and of same composition, slate, formed from shale and of same composition, marble, formed from limestone, light red, green, black, compact, fine to coarse texture, non-foliated structure. Summary: a mineral is a homogeneous, naturally occurring solid and generally inorganic substance with a definable chemical composition and an orderly internal arrangement of atoms. Minerals form in all geologic environments and under a wide range of chemical and physical conditions such as varying temperature and pressure. The 4 main categories of mineral formations are igneous, sedimentary, metamorphic and hydrothermal. Rocks are earth materials made from minerals. Most of the rocks have more than one kind of minerals. Minerals that form rocks are classified in various ways. They are classified based on visual properties, physical properties, chemical properties. Types of physical properties that geologists use include color, streak, luster, hardness, specific gravity, crystal habit, and cleavage. They are also classified based on special characteristics like reaction to acid, magnetic property, salty taste. Based on the time of origin essentiality of minerals that form rocks, the minerals are classified into three classes, namely primary mineral, secondary mineral, and accessory mineral. Depending on the proportion of light minerals to dark minerals and presence or absence of iron, magnesium chemicals, igneous rocks can be broken into four main types: felsic, intermediate, mafic, and ultramafic. Based on the combination of silicon and oxygen and other chemicals, the minerals are classified as silicates and non-silicates. Non-silicates are further classified into 6 groups. Nowadays, this classification is generally accepted worldwide. Silicates are often divided into two major groups: ferromagnesian silicates and non-ferromagnesian silicates based on the iron magnesium content. On the basis of mineral structure, the silicate group has been subdivided into 6 smaller groups, namely tectosilicates, phyllosilicates, inosilicates, cyclosilicate, sorosilicates, and nesosilicates. Thank you.